Well, I think it's about time here, and we'll go ahead and get started. I'd like to welcome all of you, and this is a small group, so we can be very informal. Please, as we go along, if you have a question or discussion, if you disagree with something, please disagree with it and let me know. Okay, and then let's try and have a good discussion, and just instead of me just sitting up here talking. So first, the commercial. So talk about Emerson, and Emerson's been very active in the environmental area for a long time, and Emerson goes back to 1890, and it's under the same name. So our revenues are now about $18 billion a year. We're active in almost every country in the world, in selling products somewhere or the other. And we have installations in almost every refinery and almost every major chemical plant around the world. So very active in the industrial area. Emerson has a push on sustainability. And so if you go to the Emerson website and search for sustainability, it'll bring you to a site that has a lot of information about what we're doing, in addition to providing tools to our clients for sustainability and environment. We've adopted that internally. We're doing a number of innovative activities in our own system to reduce waste, reduce energy, and improve productivity. So what I want to talk about is PEMS today, and perhaps a new look at software for implementing PEMS and some of the advantages of this approach. So my name again is Doug White. I'm a consultant with Emerson and specializing in refining and petrochemical, and I've been working in the process industries for many years, putting in these advanced automation systems for various types of applications. So if we start with what's the problem and what is a solution, what are the benefits of it, case study, and how to get started, and then a summary. So I think we know that environmental regulations are continuing and going to continue to get harder. If you attended the kickoff session this morning, that was the message everyone was giving, that it's not going away. It's just going to get worse in the future. So we need to make sure that we're adopting the technologies and the installations to support that. Emissions reporting is, of course, very important. And emissions reduction is important as well. And most major companies have published a sustainability document which states what their goals are for reducing emissions over the next few years. And then also there is increasing investor pressure in the sustainability area. You know, I think the very, very large hedge funds are now requiring that companies talk about their sustainability programs. Perhaps you're aware that ExxonMobil's board had a number of activists elected to it in the last shareholder meeting, whose purpose was to make sure that ExxonMobil was doing more with regard to sustainability efforts in their actual operations. So what's a solution? Well, we had a very nice presentation on SIMS earlier, and that's important. But what I want to talk about is PEMS, Predictive Emissions Monitoring Systems, where we can basically take tests from the plant for offline data and put together models that will enable us to predict what the expected emissions are. Now, PEMS has been around for a long time. It's not exactly new, but what we're going to talk about is implementing it in a new and modern software framework. In other words, being able to take advantage of what we have available today in software to enable us to do more. So we can think about PEMS in terms of 4 different levels. First of all, the standard predicted PEMS, which is data-driven models to estimate predict emissions. An extended PEMS, which enables us to add automated root cause analysis and real-time diagnosis of avoidance events. Third is add optimization models that will provide recommendations on how we should operate the plant to optimize the production within emission limits. And then finally, fourth, which is equipment monitoring, which enables us to extend the PEM structure to maximize equipment availability. So again, the idea with PEMS is that we put together a model that enables us to predict emissions, typically of items such as CO2, CO, methane, SOx, and NOx emissions from the equipment such as gas turbines, gas engines, boilers, and flares. So how does it work? Well, again, we have a model and we bring the model data into our prediction system. First thing we must do is we want to do sensor validation. We want to make sure that the values that are going into the model are within the range of our data that we have used to develop the model, that there's no obvious problems with it, that it's within the right range, the limit checks, deviation limits, and use all that to make sure that the data going into the model is as good as we can get it. And then in some cases, if it turns out we have a single faulty sensor, we may be able to go back to an alternate way of calculation using some type of data reconciliation approach. And basically, then this validated data goes to the emission models, which enabled us to predict then, which we can use for actual emissions predictions, for reporting, for alerts, and for recommended predictions or for data calculations and savings as well. There are many PEMS deployment options, okay, and that's one of the big advantages. Of course, this can be done as an on-premises platform. It can be done on an Emerson cloud. It can be done on a customer cloud. It can be done using a data lake. So one of the advantages is the ability to have different possibilities for where we actually implement this. Now, so what is different about Emerson's PEMS? Well, it's based on a software framework that first of all includes modeling and optimizations for building the model. And this is a very rich set of predictive models. It includes all the standard statistical approaches. It includes neural net possible predictions if necessary. So it can fit just about any data set that it is possible to bring to it for predictions. Then secondly, we have a section which enables us to detect if there are exceedance events predicted, and then tell the model what to do to check for cause and effect. Finally, it includes root cause analysis, which enables us to online look at the implementation of fault tree models to automate the root cause analysis of avoidance events. And then finally, a workflow engine, which enables us to put together what the program should be to fix this. So then a typical PEMS project involves, first of all, data acquisition and model training, okay. Then a deployment. Then, as we mentioned, data acquisition and validation. And then finally, the PEMS model validation and then actual deployment to the site. So this requires some expertise in the use of these models and programming, and would say that consulting and project services are available to help if needed at the site. So let's now say, you know, if we have prediction of a potential exceedance event or an actual, then what we might like to do is to go back and figure out where is this cause, what's causing this. And so one of the, again, as I mentioned before, one of the modules available is an asset root cause identification. What does that give us? And basically, it gives us a fault tree so that if we have an indication of a problem, so we have an indication that there's a problem, an exceedance event is predicted. Then we're going to go back to some of the primary causes that it could be, and that will go back. And then it goes into the fault tree itself to identify what the potential fault areas are, and then identifies what the actual specific cause of this exceedance event is from. And this can then be tied in with what can we do to actually fix the problem, so it'll give us an indication of where we need to go to actually look at the problem and fix it. So this, for the pre-configured, now this involves, you see, a lot of fault tree numbers here. How do you build such a thing? How do you get started in doing it? Well, it turns out we have a library of templates of these equipment, of standard equipment that would provide a fault tree to start with. Now, every site is going to have some specific things that are different than the general one and some that need to be added. But you can start with a pre-configured fault tree that will make it very easy for you to decide whether you have all the complete information you need or whether you need to add some more. And this is alerting you in real time. So the operator is there, they receive an alert on a predicted exceedance event. They then are able to click on this and go back and follow the fault tree back. Each of these is highlighted on the screen for the active areas. And then it goes back and tells the operator, okay, this is the likely reason for this problem occurring. And so here is what you should go do to check it and make a correction. Right? So that's a significant advantage over traditional SIM systems, the ability to get this diagnostic information and go back and use that as a basis for deciding what to do. Now, there's a third area. Clients also want to know, in many cases, if they have complex equipment sets in the plant, how can they operate the plant to maximize production, but still stay within their exceedance limits or in their emission limits? And so the next possible implementation is to add in future emission predictions based upon a future program of equipment use. So you can actually look forward and say, this is what we would expect to happen as you bring this equipment online, and this is how to operate it in an optimization, in an optimum way to maximize your production and still stay within your emission limits. Now, on the modeling and optimization side, it's almost impossible to list all the different mathematical techniques we have available to do modeling. But basically, it includes, first of all, model capture and validation for building the models, then various ways of looking at whether or not there are particular regions where the models are more effective and we need to change models from one region of operation to the other. And then all of this whole list of different types of mathematical technologies to actually fit the data. So it's almost impossible to imagine data that it can't fix. Okay. So anyway, it's very rich, very, and it provides a lot of very nice tools to be able to do that type of prediction. And then on the question of optimization, we provide dynamic, what's called dynamic targeting. In other words, how should you operate in the future to maximize production within equipment limits? And it considers what equipment is available, what the operating modes are, special events that are expected to occur. What are you predicting as the way you want to operate? What's our load present? What's seasonal factors? All of those things that might impact the expected emissions. And that then comes out then with an optimum target for operation to be able to maximize that. Now, and then the fourth thing you can do is to add capability here. This is the same framework of software that we use to do equipment reliability and availability checking. So this can be extended easily to do equipment monitoring and to do more than just emissions check, but to do efficiency checks, to do actual checks on required maintenance, how the equipment is predicting to operate, and provide you with guidance on what you should do to operate that way. So in addition to the emissions, then it can give you a health index on the equipment. It can tell you what you should do and what are the potential areas. So what are the potential benefits of using this? Well, generally stated that with SIMS, it costs about 50% of the capital costs of doing the PEMS cost about 50% of the cost of doing a SIM system. The project implementation is very quick. You don't require additional physical connections to the process, so it can be implemented in weeks rather than months. It's higher availability. A typical availability on PEMS system would be 99.5%, and SIM system would be of the order of 95% if you consider in typical calibration, maintenance, and other activities that are involved. The other thing is, as you get new data, as the plant changes, you can update the models. Okay, so that makes it easy to update the models online. This meets the US EPA regulations and also the EU requirements for SIM system. Now, one of the other things that I think is a big advantage is it's very scalable. It's easy to replicate this across multiple sites. So if you have multiple sites with similar equipment, you can take what you've done at a previous one and use that to quickly come up to speed on this new site. And then finally, it facilitates centralized monitoring and maintenance. So this is software. It's presenting results. The models are available. So you can, if you have a central engineering group can actually maintain this and download changes. So you don't have to have necessarily experts in this type of technology at every site. You can have the experts in a central engineering group, and they can then use this to monitor this. So let's look at a case study. This is a prediction emission system that was put on a international majors FLNG vessel. The PEMS solution is based upon Emerson's plant web optic analytics for predictive modeling, and it's according to the European standard. The models include a gas turbine, boilers, gas engines, a flare, and a thermal oxidizer. And the composition predictions include CO2, CO, methane, NOx, and SOx. So this is the type of display you get on the system. You can see over in the left-hand bar the different equipment that's there. And so if you want to look at a particular piece of equipment, for example, here's one of the boilers. So you can use it to look at what are its emissions of different types of emissions predicted. Okay, and what's been the trend? If there are any expected problems. So this would be the type of KPI data that you could get from the system. And then finally, here's an example of the predicted overall emissions from this vessel in different areas and for each of these, and what are the contributors to it from different pieces of equipment. So how to get started, if this is something that seems of interest, well, there's basically an assessment phase that goes into the implementation. First of all, you would go, basically it involves an on-site and off-site component where you would go and interface with various people who are going to use this, decide what the workflow is, what needs to be done to change it for implementation. And then secondary off-site, then pre-validate the information that you have, so you make sure you have all the information you need to build the models. And then you can produce a opportunity feed assessment of deliverables of different options and what their payout will be, what's the, versus estimated cost and effort versus the estimated benefits. And so this is provided as part of the standard reporting from this type of a system and give you an indication of different options for the system itself. So kind of a summary. Utilizing a predictive emissions monitoring system, as we say, it's generally easier and faster to implement and cheaper. You can manage this from a centralized location. You can have a savings in capital costs and also a savings in maintenance costs, and provides a continuous approach that you can do. Now, some of the key requirements that we think are important for the software to do this, first of all, it needs to be a standard platform. So that's what this is done in a standard software platform. It's maintained by Emerson. It's updated with new operating system changes and other things so that it has continued to function. It's got flexible deployment. It's easy maintenance to look at this. As I said, the modeling capabilities are extremely large, and then it can do the root cause analysis to help you identify where potential problems are. Scalable and expandable, so you can do it across multiple sites easily, and across and maintain it from a central location. So we have two booths here, 4307 and 4308. I invite you to come by and take a look at this and talk about that. So questions, comments? Comments?